Hello coders, welcome back to another video, and in today's video we are going to be modifying our bootloader to actually load in our kernel. And how do we do this? Well, that's actually fairly simple. What we're gonna do is just define a function and it's going to load our kernel. So without further ado, let's get straight into the code. Now, the first thing we're going to do is we are actually going to be defining a make file. And this make file is just going to make sure that we don't have to keep typing the same commands. It gets annoying. So, what we're going to do, and oh, I missed this in the last video, we have to define bit 16 at the top of our boot.asm. And that's why our print string function wasn't working before with the original compiler method. So, that being said, we are going to create a make file. So just create a make file, and you have to put it like this, I believe. You might be able to do a lowercase m, I'm not sure, but it has to be make file. And we are just going to type boot.bin. Well, okay. So we are going to create a final file that's going to be OS image. So OS-image is going to be our target, and it's going to rely on boot.bin and what we're going to call kernel.bin. Now we haven't learned how to create the kernel.bin, but we will. So how are we actually going to create this OS image? Well, we are going to first create our boot.bin, which is going to rely on boot.asm. And we create the boot.bin by doing nasm-f elf32 -F dwarf boot.asm-o boot.o. Now what we do is pretty simple. We're just going to link it. So ld-m elf_i386 -T text 0x7c00. And what we have to do is we have to remove the org. I've already removed it, but you can just change the org for bit 16. If you don't remove the org, this won't work. So now after you've removed the org, you can go back in. So ld-m elf_i386 -T text 0x7c00, which is just going to tell it where to actually put it. And then what we have to do is boot.o -o boot.elf. And we're not done yet. Now we have to actually create the binary file. So object copy -O binary boot.elf boot.bin. And this is going to create our bin, and then we can just remove our boot.o and boot.elf. You don't have to do this last two parts, it just cleans up the workspace a little bit. And now what we're going to do is we're going to create our kernel.bin. And our kernel.bin is going to rely on kernel.asm, which we haven't created yet. So nasm-f elf32 -F dwarf kernel.asm-o kernel.o. And it's just going to be the same as these. And if you know a lot about makefiles, you don't want to define a, I don't know what the technical word for it is, but you don't want to do this yet. You don't want to do .o .bin or .c or whatever. You don't want to create a suffix target yet, because this is going to change. So now what we do is ld-m elf_i386 -T text, and this is going to be very important, 0x7e00, and that is going to put our kernel 512 bytes after our boot.asm. So our kernel is literally going to go right here in memory. It's going to go directly under our boot.asm. That is OBS. Okay. And after we've done that, we can just do the standard boot.o, no, not boot, kernel.o -o kernel.elf object copy dash capital O binary kernel.elf kernel.bin. And then we can just remove kernel.o and kernel.elf. And that should be that done. And now we have to actually create the OS image. And the way we're going to do that is we're actually going to specify disk.image. And what we're going to do is we're going to do dd if equals -dev -0 of equals disk.image bs equals 512, which stands for boot sector, count equals 2882880, which is going to be a 1.44 floppy, and that should be good for that. Now we're going to do dd if equals boot.bin of equals disk.image bs equals 512 conf equals no trunk. And then we're going to do the same thing for kernel, but we're going to actually put it in the next sector. So dd if equals kernel.bin of equals disk.image bs equals 512 conf seek equals 1 conf equals no trunk, which is going to create our disk image. Now we should be able to run make, and you're going to get no rule to make kernel.asm needed by kernel.bin. So we're actually going to create our kernel.asm now. So if you create a new file, so if you create a new file and call it kernel.asm, what we're going to do is pretty simple, db0, and that's it. And now what we can do is go into our boot.asm and actually load the kernel. So, we're going to create a new function, and this is going to be called kernel load underscore kernel. And what we're going to do is we're going to move AH0x02, which is going to tell our boot to load the kernel. Actually, before we do that, we have to set up the stack. And setting up the stack is pretty simple. MOVBP 0x0 we'll just do 8000 MOVSPBP, and yeah, now we have the stack set up. Now we can just go into load kernel, push A, push specifically DX, and now we can move AH 0x02. We can move I forgot what we have to move now. I am going to reference. So boot.asm. Okay. We can move AH, and then we can move ALDH, and then we can move CH 0x00, if I can actually type. Okay, and then we're going to move DH 0x00, and then we should be able to call 0x13. We're just going to verify. Oh, we have to move CL. MOVCL 0x02. Okay. Now, what does this do? Well, we tell our kernel that we actually want to load. Then we want to move into AL the amount of sectors. Then we want to move into CH the head. And into we move into DH the head, and we move into CH the cylinder. This is hard drive specific stuff. You don't really have to worry about it too much. And then we move CL, the sector we want to start reading from, and then we tell it to actually run. So, an interesting thing about 0x13 is it sets the carry flag if it fails. So, if we want to check if our disk read failed, we can just say jump JC and then whatever label to handle the disk read. So we're going to jump to disk read underscore error, and we're going to ignore that for now. And then we're going to pop DX, and we push it up here. And then we're going to compare DH to AL, and then we are going to jump not equal disk underscore read underscore error. Now, what does this do? Well, we are going to pop dx, which is going to put into our DH register the amount of sectors we wanted to read, and then we're going to compare it to the amount of sectors we actually read. And then if for some reason we didn't read the same number of sectors, we are just going to jump to disk read error. And disk read error is pretty simple. We just do that, and then we do move bx, and then whatever you want to call your disk read error string, we're going to call ours disk read underscore error underscore string. And then we're going to call print string, and then we're just going to halt. So, now we actually have to go into our variables and specify that this disk read error string exists. So, disk read error string, db, and then could not read disk. And then you have to null terminate that, and there you go. You should have your load kernel function. Now, what we're going to do is we are going to move DH17, and we are going to move BX, the place we want to read. And if you remember in our make file, we put that as 0x7e00. So we just move into BX 0x7e00. And then we can just call load underscore kernel. And that should work. So, what we can now do is, okay, so there's going to be a little error with this program. And it's not a big error now, but it's going to be a pretty big error later. We should actually switch these. Well. Okay, so when you set up the stack goes downwards. And we don't want to smash our kernel by setting our kernel to here. So, well, okay. Little conundrum. What do we do? We are going to leave that for now, and I will address it later. So, what we're going to do is we are going to call our make file. And you can just go into make, and yeah. And if it looks like this, everything should be okay. Yeah, okay. So that should be good. Now we can actually open up our bootloader by just running box, and we should see no difference. We got an error. Prefetch get home. Oh, did we not actually? I don't think we actually ran our OS image, so we are just going to cat box. Yes, we didn't actually run our disk image, so yeah, okay. And we are just going to change that to box. So operating system. Then whatever you decide to create, ours is disk image. Verify that it's actually disk image. Verify we have our disk image. And yeah, now we can run box, and that should work. So, no bootable device. Okay, then we didn't create our thing right. So, I'm gonna open another CMD. WSL, dot, clear. I can't type. CD operating system, CD test, ls, cat make file. Okay. Okay, so we created our file. We created our thing correctly. I'm not 100% sure why it doesn't want to work. I mean, we could try loading our kernel in a different place in memory, but it just doesn't seem like it's a valid boot. So what we're going to do is we are going to just make boot.bin. Or boot.bin, and then we're going to make it. Make boot.bin. Bin. Yeah. Okay, yeah. And now what we're gonna do is we are just gonna run box. Oh, no. Box is gonna run the dis.image and... Oh. Yeah, I forgot about that. Okay. We didn't screw up, actually, surprisingly. What we have to do is we have to run box as a 1.44 floppy as we changed it to. So, just start up a new box. Make sure this is 1.44. Click this.image. 1.44. Inserted and OK. And we can actually save that. And that is going to pop up. And then, yeah. This should run now. Oh, wait. That's the wrong one. Box. Edit. That was my test. Not my actual one. So, oh yeah, okay. So this.image 1.44 inserted and start. Okay. And we have an error. Well, what did we set our stack for the other one? So I have a pretty good feeling that it is from the stack. So we are just going to change our stack to the same exact one. Okay, we're going to change our kernel location to just 0x9000. And then we have to change our make file, so nvim make file. And we have to go down here to 0x7E00, and we have to actually change that to 9000. Yeah, that looks good, and then we can just make that, and then we can run it. So, not reset. That's going to be... Oh yeah, okay, so we make, okay, yep, and now we just call box, and then I haven't actually saved this, so I'm going to save it real quick, but if you already saved this, you can just move on to that. Yeah, okay, and now 1.44, inserted, okay, save in the actual place we want to save it in, and then start, and could not read disk. Halt instruction. Okay. I am going to be right back once I figure out why this is being weird. Alright. Welcome back, coders. I did something really stupid, and I never actually returned. So, what we have to do is pop A, and then return. And if you don't pop A, return is going to give the wrong address. So, now we can make that and go into box, and this should actually work. Yeah, that works. And now to actually prove that this works and to actually do something kind of cool with it, we are going to create a string. So we are going to db hello world. Well, we change it to something more exciting. Kernel loaded. Something cool, like hackers, I don't know. And, oh, wrong thing, 0. Okay, so we are going to print this, and yeah, now we can just go into this. And once we've loaded the kernel, it is going to load it into 0x9000. So what we can do now is we can print that. So, move bx 0x9000. And then call print string. And what this should do is we should actually be able to print the string. So, yeah. Now we have a working extended program, and now we're not actually in our boot for the entire thing. And what we're going to do is we are actually going to load into 32-bit protected mode in our boot, and this is going to be reserved for the kernel, so the kernel can execute in its own thing. So, that is this video, and we have just loaded the kernel, which is kind of cool, so you should be proud of yourself. And what we are going to do is actually nothing, because yeah, we handled everything correctly, and it should all work. So, now that you have a working boot that can load a kernel, you can do whatever you want with it. We are, in the next video, going to learn load into 32-bit protected mode, which is not as hard as it sounds, but once we do that, we can actually start doing some pretty cool things with our kernel. So, watch out for that video, and I will see you guys in the next video thing. Like always, my Discord is in the description, so if you have any issues, just come check that out, and if, you know, yeah, just come check that out. You don't necessarily have to have any coding issues, but we're a really nice community of people, so, you know, if you're looking for people to hang out with, just go check that out. And my GitHub is also in the description. I might put this onto a GitHub, but I do have an OS dev GitHub that has everything you need to get started. So yeah, that being said, I will see you guys in the next video. Bye!